Python modules. Python modules are pre-written code libraries that provide a specific functionality or set of functionalities that can be easily imported and used in Python programs. Here are some common Python modules. 1 Math module provides mathematical functions like sin, cos, tan, etc. 2 Random module generates random numbers. 3 Time module handles time-related functions like getting the current time, sleep, etc. 4 OS module interacts with the operating system, providing functions like creating directories, changing directories, etc. 5 SYS module provides information about the program's runtime environment. 6 RE module supports regular expressions for pattern matching. 7 Statistics module provides statistical functions like mean, median, mode, etc. 8 tkinter module creates graphical user interfaces, GUIs. 9 Pandas module handles data manipulation and analysis. 10 NumPy module supports large, multidimensional arrays and matrices. 11 Scikit-learn module provides machine learning algorithms. 12 Requests module handles HTTP requests. 13 Beautiful Soup module parses HTML and XML documents. 14 Flask/Django module web development frameworks. 15 SciPy module scientific computing library. To use a module, you need to import it using the import statement. For example, import math or from math import sin, cos. Note, this is not an exhaustive list, and there are many more modules available in Python's standard library and through third-party packages. Python module, a reusable code block. What is a Python module? In Python, a module is essentially a file containing Python code. It can define functions, classes, and variables. The primary purpose of modules is to organize code logically and promote reusability. Think of it as a toolbox filled with tools, functions, that you can use in different projects. Why use modules? Code reusability, write functions once, import and use them in multiple scripts. Organization, break down large projects into smaller, manageable modules. Namespace management, avoid naming conflicts by creating separate namespaces for different modules. Code sharing, distribute modules as libraries for others to use. Creating a module. To create a module, simply create a new Python file with a .py extension. For example, my_module.py. Hashtag my_module.py. Def greet, name. Print, f hello, name. Def add, x, y. Return x plus y. Importing a module. To use functions or variables from a module, you import it using the import statement. Import my_module. My_module.greet, Alice. Result equals my_module.add, 3, 4. Print, result. Using from, import. You can import specific functions or variables directly. From my_module import greet, add. Greet, Bob. Result equals add, 5, 6. Print, result. Module as a script. A module can also contain executable code. This code is executed when the module is run directly as a script. Python. Hashtag my_module.py. Def greet, name. Print, f hello, name. If __name _main__. Greet, world. Standard library modules. Python comes with a rich standard library containing modules for various tasks like file I/O, math operations, regular expressions, and more. For example, import math. Result equals math.sqrt, 16. Print, result. Packages. As your project grows, you might organize modules into packages. A package is a directory containing multiple modules and an __init__.py file. Key points to remember. Module names should be descriptive. Use clear and concise function and variable names. Add docstrings to explain the purpose of functions and modules. Consider using version control for your modules. Would you like to see examples of specific modules or learn about creating your own packages? Let's explore examples of specific modules and creating your own packages. Examples of specific modules. 1. Math module. Import math. Print, math.py, #output, 3.14159. Print, math.syn, 3.14, #output, 0.001593. 2. Random module. Import random. Print, random.randint, 1, 10, #output, random integer between 1 and 10. Print, random.choice, apple, banana, cherry, #output, random fruit. 3. Time module. Import time. Print, time.time, #output, current timestamp. Print, time.sleep, 2, #pause execution for 2 seconds. Creating your own packages. 1. Create a new directory for your package, example my_package. 2. Create an __, link unavailable, file inside the directory to make it a package. 3. Add your modules, Python files, to the package directory. 4. Import your package in another Python file using import my_package or from my_package import my_module. Example package structure. My_package /__, link unavailable. Link unavailable. Link unavailable. In, link unavailable. Def greet, name. Print, hello, name. In another Python file. From my_package import my_module 1. My_module 1.greet, John, #output, hello, John. Let me know if you'd like more examples or details on creating packages. 1. The math module in Python provides access to mathematical functions and constants. Here are some of the functions and constants available in the math module. Constants. Math.py, the mathematical constant pi, 3.14159. Math.e, the base of the natural logarithm, 2.71828. Trigonometric functions. Math.sin, x sine of x. Math.cos, x cosine of x. Math.tan, x tangent of x. Math.assin, x arcsine of x. Math.acos, x arccosine of x. Math.addin, x arctangent of x. Hyperbolic functions. Math.sin, x hyperbolic sine of x. Math.cosh, x hyperbolic cosine of x. Math.tan, x hyperbolic tangent of x. Exponential and logarithmic functions. Math.exp, x exponential function, e⁻x. Math.log, x natural logarithm of x. Math.log10, x base 10 logarithm of x. Power and root functions. Math.pow, x, y x raised to the power of y. Math.sqrt, x square root of x. Rounding and remainder functions. Math.ceil, x ceiling function, rounds up to nearest integer. Math.floor, x floor function, rounds down to nearest integer. Math.modf, x returns the fractional and integer parts of x. Angular conversions. Math.degrees, x converts radians to degrees. Math.radians, x converts degrees to radians. Other functions. Math.fabs, x absolute value of x. Math.factorial, x factorial of x. Math.gcd, x, y greatest common divisor of x and y. Note, this is not an exhaustive list, and there are many more functions and constants available in the math module. 2. The random module in Python provides functionality for generating random numbers and making random selections. Here are some of the key functions and features. 1. Random number generation. Random returns a random float between 0 and 1. Uniform, A, B, returns a random float between A and B. Randant, A, B, returns a random integer between A and B. Randrange, start, stop, step, returns a random integer from the specified range. 2. Random selection. Choice, sec, returns a random element from the specified sequence. Choices, sec, weights, returns a list of random elements from the specified sequence, with optional weights. Sample, population, k, returns a list of unique random elements from the specified population. 3. Shuffling and sorting. Shuffle, x, shuffles the elements of the specified list in place. Sort, x, key, reverse, sorts the elements of the specified list, with optional key function and reverse flag. Example usage. Import random. Hashtag random number generation. Print, random.random, hashtag random float between 0 and 1. Print, random.uniform, 1, 10, hashtag random float between 1 and 10. Print, random.randant, 1, 10, hashtag random integer between 1 and 10. Hashtag random selection. Fruits equals apple, banana, cherry. Print, random.choice, fruits, hashtag random fruit. Print, random.choices, fruits, weights equals 1, 2, 3, k equals 2, hashtag random fruits with weights. Hashtag shuffling and sorting. Numbers equals 1, 2, 3, 4, 5. Random.shuffle, numbers. Print, numbers, hashtag shuffled numbers. Numbers.sort. Print, numbers, hashtag sorted numbers. Note, the random module uses a pseudo-random number generator, which means it generates numbers that appear random but are actually deterministic. If you need cryptographically secure random numbers, use the secrets module instead. 3. Time module. The time module in Python provides various time-related functions. Here are some of the key functions and features. 1. Current time. Time returns the current system time in seconds since the epoch, January 1, 1970. Perf_counter returns the value of a performance counter, which is a clock with the highest available resolution. Process_time returns the sum of the system and user CPU time of the current process. 2. Time formatting. Time returns the current time in UTC, Coordinated Universal Time. Local time returns the current time in the local time zone. Strftime format, T, formats the time according to the specified format string. 3. Time parsing. Strptime, string, format, parses a time string according to the specified format string. 4. Sleep function. Sleep, seconds, suspends execution for the specified number of seconds. 5 time zone functions. Time zone, TZ, returns a time zone object with the specified offset. Alt zone, returns the time zone object for the local time zone. Example usage. Import time. Hashtag current time. Print, time.time, hashtag current system time in seconds. Print, time.perf_counter, hashtag performance counter value. Print, time.process_time, hashtag process CPU time. Hashtag time formatting. Print, time.time, hashtag current time in UTC. Print, time.local time, hashtag current time in local time zone. Print, time.strftime, %y-m-%d%h%m%s, hashtag formatted current time. Hashtag time parsing. Print, time.strptime, 2024-03-1614:30:00, %y-m-%d%h%m%s, hashtag parsed time. Hashtag sleep function. Time.sleep, 2, hashtag sleep for 2 seconds. Hashtag time zone functions. Print, time.timezone, hashtag local time zone offset. Print, time.altzone, hashtag local time zone object. Note, the time module uses the system's time zone settings, so the output may vary depending on your system's configuration. 4 OS module. The OS module in Python provides a way to interact with the operating system and perform various system-related tasks. Here are some of the key functions and features. 1. Process management. Fork creates a new process by duplicating the current process. Execv replaces the current process with a new program. Wait waits for a child process to terminate. 2. File and directory management. Chr changes the current working directory. GetCould returns the current working directory. Mkdir creates a new directory. Reamdir removes an empty directory. Listdir returns a list of files and directories in the current directory. 3. File permissions. Chmod changes the permissions of a file or directory. Access checks the accessibility of a file or directory. 4. Environment variables. Environ, a dictionary of environment variables. Getenv returns the value of an environment variable. Putenv sets the value of an environment variable. 5. System information. Uname returns information about the operating system. Sysconf returns information about the system configuration. 6. Miscellaneous. System executes a command in a subshell. Pipe creates a pipe, a unidirectional communication channel. Example usage. Import OS. Hashtag process management. PID equals os.fork. If PID equals 0. Print, child process. Else. Print, parent process. Hashtag file and directory management. os.chr, /path/to/directory. Print, os.getCould. os.mkdir, new _directory. os.reamdir, empty _directory. Print, os.listdir. Hashtag file permissions. os.chmod, file.txt, 00755. If os.access, file.txt, os.r_ok. Print, file is readable. Hashtag environment variables. Print, os.environPath. os.environ new underscore var equals new underscore value. Print, os.getonv, new underscore var. Hashtag system information. Print, os.enemy. Print, os.sysconf, sc underscore page underscore size. Hashtag miscellaneous. os.system, lsl. Pipe underscore fd equals os.pipe. Note, the OS module provides a way to interact with the operating system, but it's important to be aware of the potential security risks and use it responsibly.